Hey guys and girls, welcome back to another beautiful video on this beautiful channel, on this beautiful day. What we're going to be talking about today is a little more general about this whole programming industry thing and on all the related sub-industries within programming. Like, what is important and what do I need to know, what do I need to do in order to be a programmer or be someone who just knows something about coding in general, right? Like just knowing this is important because a lot of people lose motivation, they lose their drive to pursue a career in IT because it's kind of like, or in game development or anything, because it's so daunting, right? And I was real close to just giving up because there's so much stuff. Like, what do I want to do within IT? What do I want to do within, programming with my life, right? And it's like really deep questions that you might ask yourselves. We're not going to go through all that stuff, but what is important is that there are a few like basic kind of fundamental parts to programming, and specifically programming, like that you need to know and how to operate, and what sometimes you want to know everything within a field, and that's great. Like, you're supposed to know everything, right? At the end, like after a while, you just pick up information and you know more and more, and in the end you know everything about computers or programming. But in the beginning, like when you start off, like how much do you need to know, bare minimum, in order to move on as a programmer? Now, if you're going a course, if you're going to program, like like a longer university program, and then you're probably gonna get to know all these things. You're gonna eventually learn. But even in these types of scenarios, like in these environments, they don't go through all these things. They find some of these things to be self-explanatory, which I didn't, and a lot of people don't. They don't see as clearly as the teachers and people who lay out these programs, how they don't see this stuff sometimes, and we suffer, right? So I suffered. I didn't really know where to start learning specific things, and I never got these basics that would have helped me along the way really well. Now, to start off, like, people think that learning C++ or a programming language is everything you need to know, right? Then you can start coding, you can do whatever you need, and this is kind of like the first point in this video. This is point one. All right, note that down. This is not true. Like, you need to learn a programming language, of course, but what is a programming language? Like, it's these questions that you should know as well. Like, everything is built upon hardware code, right? Your computer runs on hardware code, your phones run on hardware code, everything runs on hardware code, and you have a bunch of different parts to the computer. You have the graphics card, you have all these things which run like in a specific way, right? And you have your operating system like Windows. Like, what is all this stuff, and what is C++, right? So there are different levels of programming languages, right? Some are high level, some are low level. Now, some allow you to communicate with hardware a lot more than others do. Like, if you have a language like Python, which is really, really simple, like it doesn't allow you to communicate with hardware directly. It doesn't allow you to customize a bunch of things, make all kinds of programming decisions in Python. That's why you can't write, or you can, but you probably don't want to write games and stuff in Python, because you don't have that amount of control over memory and stuff within that language. Now, one thing you need to know is all these programming languages, they get translated like a Google Translate. Think of it as a dictionary type thing. They get translated into hardware code in the end. When you compile, if you have Visual Studio Code Blocks or something, you're writing your code, that compiler and that environment you're coding in, like code blocks, everything has a compiler, right? And that translates. That's the function of the compiler. It translates your code from human kind of language to this annoying, incomprehensible hardware code, which you can also write in, like assembly and stuff. Like, people used to do that, but that's why people invented C++ and programs like this, to make it easier for you, so you can code in your own way, in a more comprehensible way, and the code will be turned into hardware code, and it will be made into a program which you can run on the operating system. Now, like I said, how much control you have over the hardware depends on your language, the language you're using, because different people invented different types of languages for different purposes. Now, if you have a scripting language like Lua, you can run that and it will compile in real time while your program is running. So you can use it externally. You can like code stuff, and within your program it will change in real time. So scripting languages, you have scripting languages, you have regular programming languages which you compile, make into a program, and then you have a bunch of other like HTML and web languages and stuff like that. And everything controls your hardware. So just remember that. And the hardware, the way that runs is controlled by drivers. That's what drivers are. They're like a interface between the hardware and the operating system. You know, so it just sets the limits for what your graphics card can do, for example. So changes in that affects how it runs, basically. And all the functions for the graphics card, like what you can do in the memory and stuff, all comes through the drivers. So there are different layers, right? And there are a bunch of things you can learn about that. So go and check that out. Go and search for operating systems, learn how they work, kind of like what layer they're in. So operating systems don't need a GUI like this. You don't need a GUI mouse and stuff. We used to have console, like a console popping up where you can type in directly, like Linux, right? But Windows and stuff have a graphical interface which helps you control all the stuff here, with folders and all that stuff, directories. And yeah, so that's basically point one. Now, to summarize point one, just that, what is a programming language, all right, and hardware code. That's what we're talking about. Now, point two is what IDE to use, or if you want to use an IDE at all when you're programming. Do you want to use Visual Studio, or do you want to use code blocks, or do you just want to use the Windows compiler and just write your code in notepads and stuff like that? People have different preferences, and you can compile it through the console. Use the regular compiler, and now you know what a compiler is, the translator to hardware code. And knowing this is really important, so you can choose your IDE differently. Now, point three, I guess, is something that is really, really important. Now, when I started coding, I didn't know how to make a window. I didn't know how to make visual kind of, all that stuff. Like for games, right? You need a window. For programs, you need a window, right? You can't just do everything in a console. So how do you do that? Now, learning this took a bit of time because nobody taught me, and I couldn't find that in any C++ book, basically. Now, for this, you need to learn something called an API, or you need to get an API, an application programming interface. Now, this is a library someone else has written that contacts a specific hardware piece, like your graphics card or something like that, and it helps push pixels to the screen or something like that, right? And it has its own kind of coding syntax or language and own functions that you can access, and you calling that function with specific parameters will do something on the screen, right? So if you want to create a window, for example, if we go to the SFML part, this is an API. It's something that you need. Besides learning C++, you need to learn this as well. So in order to get a window up, and regularly what people use for example, games and stuff is the Windows API, their own kind of window handling system, and to push pixels to the screen like that. And that is really complicated and annoying. SFML is built on OpenGL, which in turn has its own window kind of handling stuff. And you can just go in here and you can learn. Like you download it, you link it, which I'll talk about soon, and then you can check my tutorial out on getting started with this, and just go ahead and link it with Visual Studio or something, and then you'll go ahead and make a window. Now this function is what I was talking about, a API function. So it will call this if you include everything correctly. And this SFML knows how to contact your hardware, and some person has sat there and coded this, like hard coded, like hardware code, to tell exactly what this function does, and it pushes out a window on your screen. And all you have to do is write a few lines of code. If you didn't have a API like this, you'd have to go in, make some hardware code stuff, and just billions of lines of code, probably. I don't know. No, that's an over exaggeration, but thousands of lines at least to make a window, and someone has done this for you. That's what APIs are. They make your life easy. All right. OpenGL is an API. DirectX is an API. You might have heard of these things, which people make games in. These are libraries which you link to your program, which give you these functions that you can use in order to go a step further with your programming. Make windows, make specific pixels, manipulate points, manipulate your graphics card, tell it what to do, because without that you can't contact your graphics card just with C++. That's contacting your CPU, and it's telling it what to do and kind of multiplication and all this stuff. So go ahead and check that out. So libraries and linking is really important. I guess this is point 4, right? Something like that. This is really important. Now, you'll be coming across this a lot in your career as a programmer. Libraries and linking. So things you need to do in the computer. Most people make libraries of these things, like Lua and scripting libraries, SFML for window handling, OpenGL, DirectX, maybe some math libraries, or some things like someone else has made to make your life easier. These things you're going to be downloading, sometimes building them, because all you get is the source codes for these libraries. You need to build it to get these DLLs, dynamically linked libraries, and lib files, library files. Imagine just a huge library. Okay, your program is a library of books. Okay, you have all these books which you can access functions from. Now you need to add some books there. You don't have any functions for this specific task, so you download those books and you shove them in your library, and you link to those books. Like if your program is a person which is taking out some of these books from your grand library, grand archives, and putting them on a table. That is what it is. Like downloading the library is adding the books to the library, and then linking them is taking out the books, putting it on the table for you to use. Okay, so that is bare essence of it. So just go ahead and think about it that way, and it'll make it a lot easier because it's not that complicated. So for example, if you went to SFML and you said download SFML 2 point whatever, here are the already compiled versions of SFML. Okay, so if you downloaded this, you get a bunch of DLLs and lib files and include files. Those are the 3 things you usually deal with: lib files, include files, and DLLs, like I said. And the same thing is for, if we go ahead into GLFW, which is another window handling like specific for OpenGL. It handles the Windows stuff, and it doesn't let you really handle keyboard inputs and stuff like that. So it's a different type of API. Basically, it's really a lot simpler. You can't really make games with GLFW on itself like you can with SFML. So if you downloaded this, now I don't know if you get a zip file and whatever, and you can just go ahead and open that and check it out. You'll get probably lib files and stuff in there as well. The same kind of thing in every one of these libraries. The same with Lua. And this is a tutorial on OpenGL, basically. Now I'm going to talk about this now. This is kind of point 5, all right? So if you want to make a 3D game, you can get DirectX, and you can use the Windows API for the actual window, and then you use DirectX for contacting your graphics card, pushing out pixels to the screen, pushing out points, vertices they're called, and manipulating those vertices with matrices and all that stuff. That is done by DirectX. The actual window and all the keyboard handling and stuff is done by the Windows API. And if you use OpenGL, okay, you can download OpenGL, use that for all the points and matrices and all that stuff. You can download a library called GLM for all the multiplication stuff. If you want to write those formulas yourself, you can do that. Go ahead. But GLM is really nice. It can make, matrix multiplications and all that stuff for you, and just give you a bunch of functions that are useful. So download that. Download OpenGL. Download GLFW, and these 3 things. Now to reiterate, GLFW was the window handling. GLM is the math library, and OpenGL is your actual graphics card communications library, where you push out all the pixels and it tells the graphics card what to do. So these 3 things give you the ability, as well as some programming interface like code blocks or Visual Studio, and the knowledge of C++. So with this, you can make games, and that is how it works. You download libraries, you link them to your program, and then you just write your code, and then you use the functions in the correct way as specified here. For example, with OpenGL, opening a window. So what do they use here? They're gonna link something. Don't worry too much about this. They're gonna include the files. They're gonna link all the files, and they're gonna go ahead and open a window, initializing all of these libraries. There are different ways, and you're gonna have to look at tutorials sometimes to understand, because it doesn't always make sense. Like, different libraries have different initializations and functions and different ways they handle stuff. So just be aware of that. For example, for GLFW, making a window, first you go ahead and specify some functions, or specify some specific parameters for this window. You go ahead and create a window pointer, you create a new window, and then in the while loop, or if the window is shut down, all this stuff happens, and you have to terminate GLFW to free up memory, and then all of this funny stuff that you can come up with. So that's really important. Libraries and dynamically linked libraries and all that stuff. So it's important to know if you're making games and software. Now I'm struggling to find a 0.6 because I just went through a bunch of stuff. But what I can talk about, I guess, is optimization. Like, how do you make your game or your software optimized? Like, it's not always crystal clear. You don't always know really if your game is running at 10 FPS, what can I do to make it better, right? So learning about that stuff and how like different APIs handle memory, freeing up memory and stuff like that is not always that easy to learn. Now, learning that stuff will get you a long way in your career. All right, that will really help you out, because if you're a good optimizer, if you know some techniques to optimize your games and stuff like that, and optimize for loops, all that stuff, you're gonna make great games, right? You're gonna make games for mobiles that look great. You're gonna make games for computers that run perfectly, like on every device, and just you're gonna be a much better programmer. Knowing these small techniques can get you a long way. So get a book, some type of book. I know one book on effective C++. You can go and check that out. They have a lot of good tips on like small things that go a long way. Static casting, making sure the compiler or the computer doesn't have to do things on the fly, unnecessary things like with floats, putting the .f afterwards. If you have a million floats in your program, every one of those floats in the function, if you don't have the .f, it's going to have to convert that from a double to a float, and it takes a bunch of processing power. Like all these small things, how you make a function inline, making sure that the function is returning constant values, maybe if it needs to. All these small things put together go a long way. Like a car, which you just shave off 1 gram from every piece, and you end up shaving off maybe like 100 kilograms in the end. You know what I mean? Like, it's really important to optimize from the get-go, from the start. Knowing these things isn't always clear, and some people don't teach you that stuff, so you're gonna have to learn that. And this stuff with the libraries, like I said, going back to that, is really important. Knowing how to run your library, knowing a good way to do stuff in your library, in your specific library. And now come to point, what is it, 7 now, probably, is where you learn stuff. Like, where's a good way to go ahead and learn stuff. So if you're a game developer or a person who wants to be a game developer, your first step should be to learn C++ or Java. Or I'd recommend C++. It's the industry standard. So go ahead and do that. Learn everything. Really important parts of C++ is pointers. It's not that hard. It might seem daunting at first. It's not that hard. That pointers is your key to memory management and just making effective games, or managing memory effectively, I mean, optimizing and stuff. So pointers, really important. Multi-dimensional arrays, how to handle that stuff with pointers. Pointer arrays. Now I have tutorials for all this stuff on my channel. Go and check that out. You need to learn all that stuff, and classes, like how you make effective good classes, which really help you out in programming. So go ahead and learn this and optimization things and all that stuff. There's a bunch of good pages to learn all this stuff, like learncpp.com if you don't want to get a book, but I'd recommend a book like a object-oriented programming in C++, or like some kind of introduction to C++. You don't need a lot more than that, but pages like this, YouTube videos, have a lot of good explanations to everything. Bucky's tutorials, my tutorials, whatever, just go ahead and watch them. And then you got tutorials in SFML. You can just go ahead and learn here. I'd recommend starting off with SFML because it's really easy to get a window and some graphics going, simple graphics, like with shapes, like a shape moving across the screen. And YouTube tutorials for SFML, really good place to learn. So that's 2D graphics. Now if you want to do 3D, I'd recommend something like Sonar Systems tutorials, where he really goes through setting up OpenGL. I'll be making these as well, but he goes through setting up OpenGL, to what matrices you need to use, to drawing out a triangle, to drawing out quads, which is a box basically, and the camera system. Everything just goes through everything you need to know. And this stuff, knowledge about libraries, really comes in. So go check that out, and don't be scared. Like, there's a bunch of ways you can learn, but these are like the steps you need to go through. So learn C++, learn your API, graphics API, and there's stuff like Qt and Embarcado, which is like specifically made for, you know, UI for like programs, not games, but maybe programs where you can just put in buttons and stuff. And that's also an API. Like, someone made it for you to make easy graphical interfaces. But in SFML, like, you'd have to make your own class for a button, make sure that button is handled, like when you press it, when the mouse is within the button's parameters or bounds, it's pressed or not. All that stuff you have to code yourself. You can make different kind of buttons and stuff, but you have to do it yourself. Now, Embarcado or Qt has made that possible, or made that for you, so you don't have to actually do the code, all that stuff. So you can try that out as well. Qt, I think, is free. It's actually just spelled Q and a T. So go and check that out. And if you know Java, you know Java's own window handling and GUI interface stuff. You can play around with that. So don't be scared into transitioning quickly into the graphical part, because that's how you make programs basically. And yeah, I just want to cut this video off now because it's been too long, but I hope this helped you just in understanding what you need to do. I've been rambling a lot, but thanks for listening. I hope you learned something. Take care, and go ahead and go into these tutorials and just see what you can do from this, and learn as well, just as a finishing note, just learn about the graphics pipeline, because that's really, really important. Like, I can tell you what that is really quickly. Like, if you go into drawing polygons, you can go ahead and see what this is. This page is called open.gl, and you just go ahead here and you can see what the rasterizer does and what the points are in 3D programming, and where the coordinates are. Coordinates are always at 0, 0 for your screen, and all that stuff. Just go ahead and check this out. Shaders as well, all that stuff. So again, thanks for watching. Take care. I hope you learned a lot of stuff, and I'll see you in the next video. All right, bye bye.